What if the most dangerous weapon isn't a missile, but a grain of silicon etched with an unseen power? What if the battle for global dominance isn't fought in trenches or on the high seas, but in the silence of a laboratory, on a scale smaller than a human hair? For years, the world believed China's relentless technological ambitions could be contained. Sanctions would be the unyielding chains. Restrictions, the impenetrable walls. The strategic consensus from Washington to Brussels was clear. Deny access to advanced semiconductor technology, and China's pursuit of technological sovereignty would crumble. But what if that certainty was an illusion, a comforting mirage in a rapidly shifting desert? What if, while the West fortified its digital borders, an invisible engine ignited, roaring to life against all odds? This is not mere theory. This is not speculative propaganda. This is verifiable reality, confirmed by the most rigorous independent analysis. And at its core lies a profound challenge to the established global order, centered on two names: Huawei, SMIC, and a 7-nanometer chip that seemingly defied the very laws of technological gravity. Prepare yourself, because what you are about to witness, unveiled by RevoNow, will fundamentally alter your perception of power in the 21st century. If your pulse isn't racing yet, if the idea that the bedrock beneath the global tech order is undergoing a tectonic shift hasn't seized your attention, it will. Because what you're about to witness isn't just a technical footnote. It's a seismic event, a China chip breakthrough that has sent shockwaves through every capital and every boardroom. And RevoNow is your essential guide through this uncharted terrain. If you feel the urgency of this paradigm shift, hit that like button. Share this video with anyone who claims to understand geopolitics, with every analyst, every policymaker, every innovator. And most critically, subscribe to RevoNow. Because the unfolding narrative of this chip war, of the semiconductor self-sufficiency race, will redefine the rules of the game. You simply cannot afford to miss what unfolds next. For years, a silent but fierce chip war has raged. Its battlefield, the microscopic realm of silicon. Its objective, control over the advanced semiconductor technology that underpins everything from smartphones to artificial intelligence, from critical infrastructure to national defense. In 2019, the United States escalated its strategy, placing Huawei on its entity list, effectively cutting off its access to crucial American-origin technology and software. The intent was clear: to cripple Huawei's ability to design and procure advanced chips. Then, in late 2020, the hammer fell on SMIC, Semiconductor Manufacturing International Corporation, China's largest and most advanced chip foundry. SMIC was also added to the entity list, further tightening the vice. The most potent weapon in this technological arsenal? The explicit denial of access to extreme ultraviolet, EUV lithography machines. These gargantuan multi-billion-dollar instruments, manufactured almost exclusively by the Dutch company ASML, use incredibly precise 13.5-nanometer ultraviolet light to etch circuit patterns onto silicon wafers with unparalleled fidelity. For years, the global consensus, backed by every major analyst firm, was that 7-nanometer technology and anything beyond simply could not be mass-produced without EUV. It was the linchpin, the insurmountable barrier. The West's verdict on China's advanced chip manufacturing ambitions was delivered with finality, dead in the water. But then in August 2023, a ghost from the future materialized. Huawei launched its Mate 60 Pro smartphone. And inside, the Kirin 9000's processor. Initial reports were met with skepticism, then disbelief. Independent forensic teardowns, most notably by Tech Insights, provided the irrefutable evidence. The Kirin 9000 was indeed a 7-nanometer chip, and crucially, it was fabricated by SMIC. This wasn't a trick. This wasn't a misdirection. This was a direct, audacious challenge to the established technological order. The most profound mystery immediately emerged. How? How did SMIC achieve 7-nanometer without EUV lithography? The answer lies in a testament to relentless engineering and a profound strategic commitment. They utilized deep ultraviolet, DUV lithography machines, the generation preceding EUV, combined with extraordinarily complex multi-patterning techniques. Imagine attempting to carve Michelangelo's David, not with a sculptor's chisel, but with a series of tiny, repeated, less precise cuts, each requiring perfect alignment. That is the scale of this engineering defiance. DUV lithography alone cannot achieve 7 nanometer feature sizes. Its wavelength, typically 193 nanometers, is simply too large. So, SMIC employed techniques like self-aligned double patterning, SADP, and, potentially, even self-aligned quadruple patterning, SAQP. This involves splitting a single, intricate circuit pattern into multiple, simpler sub-patterns. Each sub-pattern is then exposed and etched onto the silicon wafer in separate, meticulous steps. For a single 7-nanometer layer, this could mean 4 or more distinct lithography, etching, and deposition cycles. Each cycle carries a risk of misalignment, of particle contamination, of microscopic defect introduction. The process is exponentially more complex, time-consuming, and resource-intensive than using EUV, which can achieve the same result in a single pass. The verifiable trade-off is stark. Significantly higher manufacturing costs, a dramatically extended production cycle, and critically, a much lower manufacturing yield. Industry estimates, based on detailed analysis of the Kirin 9000s, suggest a yield as low as 60%, or even less, for SMIC's initial 7-nanometer runs, meaning more than half of the processed wafers might be unusable. This would be commercially unviable for global market leaders, yet SMIC absorbed it. It's a clear demonstration that for China, this chip is not merely a product. It's a statement of technological resilience, a declaration of capabilities forged under duress. This isn't just innovation. This is the relentless, grueling process of building a cathedral in a hurricane, brick by agonizing brick. Every transistor a testament against the gale of sanctions. This SMIC 7-nanometer process represents a new chapter in the China semiconductor breakthrough narrative. This 7-nanometer technology achievement, while technically arduous and commercially challenging, represents far more than just a chip. It's a profound manifestation of China's accelerating state-backed drive for semiconductor self-sufficiency. For years, China's leadership has viewed its reliance on foreign advanced chip technology as a critical strategic vulnerability, a choke point that could be exploited by rivals. The US sanctions, far from stifling this ambition, acted as a powerful accelerant. Imagine a pressure cooker designed to contain and suppress. Instead, the pressure intensified, forcing an internal, unprecedented innovation sprint. China's response has been a colossal investment in its domestic semiconductor ecosystem. The National Integrated Circuit Industry Investment Fund, known as the Big Fund, established in 2014 and further expanded, has poured hundreds of billions of yuan into domestic chip design, manufacturing, and equipment companies. This state-driven funding, augmented by provincial and local government initiatives, allowed SMIC to absorb the staggering costs associated with its DUV multi-patterning approach for 7-nanometer technology. It allowed them to invest in the necessary talent, research, and infrastructure, even if the immediate economic returns were suboptimal. This wasn't about immediate market share. It was about technological sovereignty, about securing the foundational technology for its future. The Huawei SMIC chip wasn't an isolated engineering feat. It was the direct outcome of a national imperative. This also means that the narrative of global technological interdependence, where specialized nations each contribute to a seamless global supply chain, is now being fundamentally rewritten. The US sanctions impact has triggered a determined decoupling in critical technology areas. This China chip breakthrough signals a new phase in the chip war, one where resilience and domestic capability are prioritized above all else. It's a strategic chess move that changes the entire board, forcing a re-evaluation of how effective external technological containment truly is. The world is witnessing a tectonic shift. The plates of global power are grinding and new landscapes are emerging. This isn't just about making phones, it's about controlling the very digital nervous system of a nation and indeed, a future global order. The revelation, stark and undeniable, is this. The Huawei SMIC 7-nanometer chip isn't just about one company or even one nation defying a technological embargo. It's a profound testament to the unparalleled strategic determination and ingenuity of a nation driven to achieve semiconductor self-sufficiency at any cost. The US sanctions impact, designed to halt China's advanced chip ambitions, has inadvertently acted as a catalyst, igniting an unprecedented innovation sprint behind closed doors. This breakthrough fundamentally alters the dynamics of the global tech supply chain, proving that alternative, albeit more arduous, pathways to advanced chip manufacturing exist. It forces a re-evaluation of export control regimes and the very efficacy of technological containment. What was once deemed impossible without EUV has been achieved through sheer persistence and brute force engineering with DUV lithography and complex multi-patterning. This is the sound of the invisible engine roaring. But as the world witnesses this defiance of technological gravity, one question remains, echoing across the digital battlefields and geopolitical theaters. What happens when this unseen power, meticulously built brick by agonizing brick within the storm, steps fully into the light? How will the rules of the game truly change when the cathedral, once thought impossible to construct, stands complete? What new frontiers will be carved, and what unforeseen alliances and rivalries will emerge from the shadow of this China chip breakthrough? Thanks for watching. This is Revo Now, signing off.
Subscribe to Revo Now and join our vibrant community of forward thinkers, change makers, and revolutionaries.